before your semester break. Nanti not this week, maybe next week you got to present. You can present what you have done. You have done. Start from your PDS lah. Start your product design spec until what you have done. You guys gonna present to me your works. Nanti format of presentation I will inform in the WhatsApp. Alright, I will inform in the WhatsApp. Okay, sekarang ni you are already conducted, dah buat second evaluation matrix was done. Okay, the result from your PU matrix, second matrix. So you come out with your final design. Okay, as I mentioned before again and again, okay, it doesn't mean not necessarily the champion from your PU matrix, the number of positive is much greater. That doesn't mean the champion from your PU matrix will be your final design. Not necessarily, okay. Maybe this normally case here always based on your group punya decision. Maybe you can combine ideas, merge ideas, and so sometimes it happen like that. Not necessarily the highest point in your second matrix will be your that would be your final design. Sometimes maybe your group decision also. Maybe you combine some ideas from second champion, okay, the runner-up, or maybe you take certain positive from one of your team member punya concept, then you can merge it, combine to become your final. You can do it like that also, but you need to justify lah in your report, make some justification statement. Why you ni lah, mesti ada justification. Why you combine the ideas, right? So I need to see you punya ni lah, you got to present to me, okay? Okay, tapi for this week, okay, now you already have your final concept, So your final concept tu is your group punya decision, your group punya output, that will be your final idea lah, your final concepts, okay? So you have, from now on, you have to work on one concept. I mean, 5 of you or 6 of you will have to work on this one concept. This one final concept will be your group punya final concept. So you need to, this final concept you need to develop more lah, develop detail lagi lah, develop detail. So, okay, I show you in the live video, hold on je. Hold on je. Right. Sekejap. Kalau ada line tak clear, apa terputus ke, inform saya. Boleh nampak Boleh nampak saya punya live video?
Boleh.
Kalau ada apa-apa happen, gambar tak terbalik Betul kan? Alright. Okay, korang punya design process is like this. Confirm we have recognition of needs. Okay, ini you punya first stage. Ini your project title lah. You already given the title. Or you introduce yourself, you punya ni. Then kemudian the second one will be your problem definition. Okay, you guys have been through this already. Okay, you punya second one is problem definition, where you prepare your design brief. Your design brief, you elaborate more, then you do mind mapping, elaborate more, or objective 3. Okay, you do objective 3. Ini semua done. Okay, from there you elaborate more, so you find the information kan, then you search information or research background. Okay, you and all your team members information, then you gather together, you gather back, okay, you compile all the information and you form into PDS, right? Okay, your product design specification where PDS is very important. Okay, then after you already ready your PDS, then you go for conceptual design. Okay, conceptual design punya stage ini already done. Okay, from PDS you mean you are ready, information, everybody have the same information, have same knowledge, so you generate ideas by conceptual design. So conceptual design, the technique that we use is function block, function analysis, right? Function block or function analysis and morphological chart. From morphological chart, you have a lot of ideas. From there, you develop your own idea. So you generate ideas. So from there, you generate ideas or concept. Okay. Then you generate ideas, then you do evaluation, right? Concept, idea or concept. Ideas or concepts. Then you do concept evaluation. Then you do concept evaluation by first matrix and PU matrix. Okay, ini already done. I asked you to do during the break lah. This one already done. From the PU matrix, so the result from your PU matrix, so you have your final design. So this one will be your final concept or final design, final concept. Okay, this is your final concept. Boleh nampak my inheritance? Boleh nampak guys? So this final concept ni, kita tak straight away. Okay, final concept, that's it. That's it. Okay, this final concept, kita tak straight away. Okay, this final concept, you tak straight away go direct to detail design. You tak straight away go for detail design. Detail design mean you buat engineering analysis and engineering drawing. Engineering analysis first, dan kemudian at the end engineering drawing. After engineering, then only you do fabrication. You start doing your prototype. Tetapi kita tak straight final concept dan detail design. That one is detail design. Detail design mean you dah detail. Detail design mean you have to document all your design. You have to detail analysis. It means that you have to do engineering analysis, your knowledge from your machine component design last semester and strength and so on. You do engineering analysis and also you do ergonomic studies, that is detail design. And also you after that, after engineering analysis and ergonomic studies, then you will do engineering drawing. That one is detail design. Right? Tapi before that, what I'm talking after final concept, it means you, okay, from the result from your PU metric, okay, you and your group, okay, make a decision. This is our, you say, you present to me, this is our final concept. This is your group punya decision, this is your final concept. So this final concept had to be developed more. You kena develop more. That's my point. You kena develop. Kena develop more lah. Faham guys? Understand tak class? Develop more.
Yep.
How we develop more? Okay. Macam mana? You want to explain about your final concept to me. How do you do that? Class, are you listening or not?
Yes, Doctor.
Ini yang lain ni tak ada buka video pun. Pegang je. Lain tak ada video apa. I want you to see. Alright. Kita kena develop more. Kita kena develop more final concept. So how do you going to explain your final concept? So it means that you have to do detailed sketching lah. You have to do detailed sketch. Okay, you have to, okay, you punya final idea tu, you kena sketch lah, like your individual concept, right? Remember your individual concept, you have to produce 3 sketch, right? Kan? Assembly, explore dengan explain. Same goes for your kind of concept. Tetapi final concept, you can identify all component because, okay, this is your final concept. You need to explain, you need to discuss with your group member. You have to develop more detail about your final concept. It means you have to identify which is which. In terms of what component involved, what component parts that you design, you introduce in your system. You can identify it. Even a single piece of component, like even a single screw, bolt and nut also must be included. Understand that guys? At this moment. Faham? You kena detailkan sketching you because pasal you nak design, you guys have you want to design this thing. This will be your this is your final design, final concept. So you want to develop more. So it means that you need to identify all the things involved in your design. Kalau you design a device, you have to know everything, every part, component, bracket, supporting structure, all the component, even the component next to the component is not just, okay, this is connected like that. It's not just say like that. How does it connect? How this part connected to the second part? How this part connected to the next part? It's not just glue, hot glue like that. Is it joined by bolt and nut? Is it joined by snap fit? Is it joined by welded or something? You have to identify how does it connect. Every possible thing you have to identify in your dealer. You can develop more final concept because we want to make things happen, right? We want to make things happen. So this final concept we want to develop. This stage we don't call it detail design, right? Detail design tu I cakap engineering analysis, economic and also engine drawing. This is what we call initial embodiment design. After conceptual design, we call it initial embodiment design. Initial embodiment design inilah the first you punya task. You are now at this moment, initial embodiment. Because you already have your final concept. So your final concept to have to develop more. You kena develop more your final concept. You have to make a detailed sketching. So possible ni you must your sketching ni mesti ada BOM. Understand tak? You know what is BOM? Bill of Material, tahu tak? BOM, Bill of Material, belajarkan engineering drawing. You've learned engineering drawing dulu kan? Bill of Material. Tahu tak?
Tahu tu.
Because your sketching tu kena provided dengan Bill of Material. Kalau without that, you tak identify component macam mana. With BOM, if your sketching you have balloons yang label the component, right? Label the numbering, all the component involved, and you have a table BOM, Bill of Material, number of the components, the name of the parts or component involved, and the material what you're going to use, and the quantity. That BOM. So you have to make a detailed sketches. By hand, it is not doing by SolidWorks yet, guys. It is by hand sketching. You need to prepare a lot of A3 sketching lah. Okay, initial embodiment design stage ni, at the first task is this lah. So your punya sketching have to be more detailed, right? I mean, I'm talking about your punya final concept. So you need to identify. The first task is you got to identify because maybe at this moment you already have your punya draft sketch of your final concept, right? You already done that. Your final concept based on the champion from your geometric, for example. So you have a sketch of that guys in the champion. So this is your final concept, or maybe you merge concept. Okay, you have a rough one sketch of it. Okay, that one is just a rough sketch, one piece of paper A3. But you need to identify, you got to make it more detailed. What is, okay, since this is your final concept, you can identify all the possible component, even a single piece like screw nut also must be included. You got to identify all the components. Because this one got to be detailed. Pasal without, kalau if you make just a rough sketch of your final concept, a very rough, your punya component also you're not sure which is which, you don't identify detailed component, detailed part not included in your sketch. So your final concept is kind of like rough. You don't know how it works. It cannot be done. Because at the end nanti you kena fabricate. When you want to fabricate, you need to, all the part must be there. Kalau you don't make a detailed sketching, it's quite hard and difficult for you to follow on the next task because we need to do detailed design to make a draw analysis, so to make sure that how your mechanism works or not. So to make sure that your final concept it works, so you got to be have to be detailed. You have to identify all the components that involve, because you want to make sure your punya final design will works. At the end, you will build a prototype, right? Either physical or virtual. So all the component in single component part must be there. Okay, must be there. Okay, this is the moment sekarang. What I need you to do this week, guys. So what you have to do, you make a detailed sketch of your final concept. Okay, this is work of 5 guys, bukan work of 1 because this is a group punya work. So 5 people work. Okay, group leader have to play the role lah, delegate jobs lah. So you have to pecah, delegate and divide into this. First you discuss dulu your final concept, overall sketching, then later kemudian you punya next discussion is how you divide you punya final sketch into category. So the category dia punya subsystem lah. like the order that you agreed on your morphological chart, the function analysis. Okay, one of you make a detailed sketch on the feeder, right? One of you make a detailed sketch of the opening from the feeder, how they put the food, how they distribute the food, how they carry the food from the feeder to the conveyor, the opening. Some of you doing the detailed sketching of the conveying, how you convey the cow food into the distributor. Some of you focus on the distributor sketching. Understand guys? Faham tak apa saya kata? Detail sketching on distributor. Delegate job lah. One of you doing detail sketching code by category and category. What is the category? The one that in your morphological chart. Remember that? Betul tak guys? Hello? Are you listening or not?
Yes.
Itulah dia. So you kena follow your morphology kan already in your WhatsApp kan, you punya morphological chart kan, you have function analysis kan on your first column. That one lah, ikut that category you develop. Because I believe you develop concept based on the morphological chart, right? So it means you have to make a detailed sketching lah. So this is your final concept. Your final concept, I believe, follow the morphological chart order of the function, the order of the function. So you category ikut lah, one doing the feeder, one doing the distributor, one doing the conveyor, one doing the food, remove excessive food, something like that. So you delegate job lah. So you kena buat the detail sketching lah. Okay, the first task in your initial embodiment design ni, you kena buat detail sketch lah. Okay, detail sketch. So you punya first task ni, you kena develop more lah. Say final concept ni, this is what you call initial embodiment design. You develop more. I mean you got to, you punya final concept ni, identify all parts involved that you introduce in your final concept. Even a single, I mention again, yang tiny thing, yang jointed element tu, screw and nut yang that you introduce kena. No such thing no such thing dalam in your sketching, when you do sketching, no such thing your parts or your component floating in the air. You understand what I mean floating in the air? No such component floating in the air. You understand what I mean floating in the air? In your sketch. Faham tak kelas? No such thing component floating in the air. You understand what I mean? No such thing component floating. Betul tak?
Maknanya screw apa semua kena buat juga ke apa?
Yes. Kena introduce. You can identify where is the screw. Kalau you punya component, okay, for example, you punya feeder tu kan. Katakan your final concept is the whole system you mounted on the cage, on the kandang tu, because I believe you punya customer, your sarjana female person in charge already give you the layout plan. By now you already have the layout plan, the dimension. So how you mount you punya ni, your punya feeder on the layout, okay. So you have a sketch on that, the dimension of that feeder, the detail sketching, the dimension of the feeder, what is the size of the tank, the feeder tank, what is the shape, is it box shape, is it cylindrical shape, that is based on your final concept, the one that you, your final concept, the one that from your geometric. You have to put the dimension on your sketch, your feeder. Okay, for those of you who are doing on feeder, for those of you doing on the opening from the feeder, you focus on how you connect to the feeder. Do you connect by welded, or you connect by screw, or you connect by flange, or something, a bracket? You have to be detailed. So that's why I cakap dalam, if you look in my written development, identify all parts involved, even part involved, custom part, you mean the part that you design, and also standard part lah, any standard part involved lah. For example, bolt, screw, nuts, spring, bracket, any standard part involved, bearings, even a bearing. For example, you have a shaft. Shaft is not floating. Shaft may be supported by bearings. The bearing also is not floating. The bearing must be supported by bearing bracket lah. But what is the bearing mounted on what? Pasal let's say you have shaft kan. The shaft is how the shaft mounted on what bracket, on what platform. Shaft is supported by bearing. Bearing is where is the bearing mounted on? Chassis is on platform. That benda tu mesti everything must be included. Understand that class? Mesti detail. No such thing component. For example, your tank, your feeder tu is not floating on the air. Your tank feeder to put all the cow foods tu must be mounted on the let's say it's mounted on the wall, or maybe mounted on the ceiling. How does it connected to the ceiling? It will be bolted on the ceiling, or it will be welded, or it will be, how do you connect it? Itu must be the sketch tu kena detail. That's 1 week I want you to focus on this whole 1 week. You have to finish the sketch yang very detailed. You identify all component parts involved, okay? So ada part, every single piece component, single screw, spring, semua must be there. Because this is a must. Kenapa? Kalau you ignorekan all this part, nanti when you develop in detail design, you will face problem nanti. You don't know your work function, you don't know either you punya part ni works or not. How does it connected? How they related the parts connected to each other? Because your parts, your system is how the performance of your machine, of your system. Any part component that you introduce must be included. Even a single piece of component must be included. How you punya parts connected. So ini yang ni lah. You kena identify all part involved, and also you have to select material. This is important. This is crucial also. Select material. How do you select material of the parts? Parts that you introduce to, what is the material? Okay, certain parts of component dalam you punya final concept ni, something they are critical. Component and critical tu, kalau component like standard part tu, it's not that. Selection material tu is quite easy, straightforward lah. Maybe you select based on the standard material available there in the market lah. Tetapi there is certain part, certain component part in your final concept, like a bracket, a structure, that is critical, that is supporting weight, that is sustain load. The component that is critical. Critical mean this part is critical in term of when your punya concept, your punya system ni in performance, when you punya machine ni when running. So certain component tu they are critical, certain parts tu they are critical in term of loading, and in term of the surrounding dia punya boundary condition lah, depend on the boundary condition. Certain component yang critical tu, be careful about selection material. Nanti I show you about ada video on selection material yang crucial, only on crucial part, critical part saja yang you have to follow the way how we select. Yang component like standard part that you think you can get easily from the market, that one don't need lah. You just mention the material in the BOM lah, in your sketch. Tapi yang certain component tu, yang critical, yang supporting structure when your machine is in running, okay, this component ni yang betul dia kind like sustain load kan. Be careful about selection material. I show you the video nanti. Share you in the WhatsApp. That's the way how we select that material. Okay, so you mean at this moment you punya sketching ni, you have to identify all part, how does it assemble within each other, how does it connect within the next component. It cannot just a component just sit down, attach just like that. Cannot just, okay, this component is just like that, just attach like that. Cannot be like that. In mechanical, how is possible, how they connect to this part, how does it connect to this part. A bracket, bolt and nut, maybe a snap fit, itu you kena identify. Understand that, guys? We're talking about. You understand me or not? My point is your sketching. Everything you explain by sketching. You cannot doing explanation. You cannot explain your final concept by doing report. You have to do sketching. So your sketching have to be proper lah. Have to be in detail. Okay, because this is a 5 group works. It cannot be one sketch. It got to be maybe 5 sketches. Okay, maybe 5 sketches. One of you focus on the feeder, one of you focus on the opening from the feeder, one of you focus on the conveying, one of you focus of distributing the food, one of you yang ada, I think at the end tu kita ada apa, remove excessive food, am I right kan? Focus on that. Macam mana you have to be detailed. So but you got to communicate how you within each other lah. How it tally dengan this group feeder, how it tally dengan the opening. The tally opening, how they tally dengan the conveying, and conveying have to tally dengan the distributor. So kena so 5 person punya work have to be detailed sketches. Okay, I have to make within that week ni you kena do detailed sketching on your final concept. All parts involved pada. Saya cakap no such thing component parts that are floating. Macam you punya, for example you punya feeder. The feeder tu, is it connecting to the wall? So if it's connecting to the wall, how do you mount it on the wall? Okay, itu kena ni. Also, beside I cakap identify part, you punya sketching tu also at this moment also must have some dimension also. not that detail, tapi overall put dimension. You have to identify the size to make sure that you punya dimension tu, because nanti bila when you go to detail design later on after initial embodiment design, so you make sure that because all these things, the size to have to obey lah, because when you do this initial embodiment, you make a detailed sketching of your final concept. You make sure that the parts that when you do this sketching, make sure that all the component that you introduce and the material that you select for each part, especially for material selection for the crucial part, critical part, it obeys, everything obeys and follow all the requirement that you have set in your product design spec. So you product PDS, do not ignore it, do not throw it away. You have to make sure PDS is your checklist. The final concept that you introduce now, make sure that all the part that you introduce in your final concept, everything it obeys what is stated in PDS. In your PDS, remember you have heading like performance, you have heading like the size, you have heading like materials. Make sure all the material that you select obeys what is the requirement have been set in your PDS. Understand, guys? Component, parts you introduce, material that you select, everything obey the function of your mechanism, obey the requirement that you set in your product design specification. Faham itu yang you at this moment lah. This moment yang called initial embodiment design. Initial embodiment design, embodiment means that kita embodiment ini we got to know the boundary, the condition, every detail at the initial stage. So at this moment tu, bila you dah finish that one, nanti kita ada tools nanti later on next week I will explain to you about the design for assembly, design for manufacture. Itu pasal design for assembly and design for manufacture cannot be done unless you have already set you punya bill of material. You mean your sketching tu, you know the bill of material. That's why I cakap using sketching. That's why I cakap the importance of BOM. You know BOM kan, bill of material kan, bill of material ni is because your sketching ni have BOM. Okay, you divide, group leader have to play the role, divide, one doing on feeding, one doing on opening, one doing on conveying, one doing on distributing. Okay, I'm not sure about the stage. If you're not sure the stage is why the stages that you already agreed in your morphological chart lah. Kan ada morphological chart kan, you develop your concept kan based on your morphological chart, betul tak kan? Betul tak guys? Kelas? Betul kelas?
Betul.
Kan you have function itulah you develop. Pasal you punya final concept pun based on that, because all of you develop a concept based on morphological. So based on that lah, okay, this is your final concept. You punya yang that was you have feeder, you have, I'm not sure after feeder apa, distributor feeder opening kan. How you from the feeder, how you transfer the food to the conveyor. One doing focus on conveyor, one focus on the distributor of the food, how distribute equally to the cow. The one yang after that I forgot, you are doing this project, remove excessive food or something like that. Follow the order. So I mean you doing the sketch based on that category. Boleh? Understand class?
Faham betul.
Class, understand tak? So you pecahkan you punya sketch based on that tu lah. The order of you punya sub-function your morphological chart. Even your final concept also from your ni kan, at the beginning from morphological chart. So you punya final concept tu you divided into dia punya subsystem lah. That's my point. So you divide you punya ni, you punya team member, you do this subsystem, you do this, you make detailed sketching. Boleh buat. So ini bukan not one person, 5+5 of you doing the sketching. Clear? Clear or not?
Clear Doktor?
Okay, kalau you nak buat sketching tu, how do you do the sketch macam mana? Sketch tu tak boleh lah A4, mesti A3 at least, betul lah kan? Mestilah A3 size. A3, jadi all of you kena sketch lah. Okay. Kalau kata for example, if you look at my live video ni, punya sketch ni, katakan you punya final concept is the whole layout system. One thing tu lah yang nak cakap dengan you kan, you punya layout plan of you punya, daripada your sarjana female dah bagi ke? Layout plan tu dah bagi ke belum? Dah dapat ke belum? The layout plan of the cage of the kandang, dah ada ke belum? Class, I'm talking to you. Layout plan tu dah ada ke belum?
Macam belum.
Tak ada bahaya tu. Dah ada ke belum?
Tak pasti. Rasa macam belum.
Astagfirullahalazim. Tak dapat lagi. Orang punya projek bukan saya, oi. Kan itu saya cakap kan, tanya kan. Layout plan. Minta segera urgent immediately get it. Ask your punya ni, your client siapa person in charge there. Immediately you must have it now. Layout plan, dimension, macam mana? Katakan you punya final concept, the whole system mounted on the ni kan. Some of you, maybe some of you focus on one, I don't know macam mana. I haven't seen yet your punya final concept. I think most of you yang doing you punya tu, you buy system lah, you have feeder mounted on the ni lah, on dia punya cage tu kan, betul tak? Betul tak kelas? Kelas?
Betul.
Jadi, you punya first cache ni, first kali you kena discuss dengan your group, tengok sini tengok kelas, can you see my live video or not? Kelas?
Yes.
You kena buat, minta you punya, immediately ask you punya tu sarjana feed me, person in charge, we need the layout plan. We are doing project for you. Come on, kita tak boleh tangguh this thing cakap dengan dia. Tapi cakap dengan sopan lah Nanti kan tiba kan dia marah korang pula. Understand tak? Minta layout plan dimension tu. So this is the layout. Okay, whether you have the layout plan, then you know you punya cache. Okay, cache size tu lah. Okay, if you go combine sketch, something like that. So this by hand sketching lah. Jangan use SolidWorks lagi guys. No, this is sketch. Pasal this is our final design. Kita masih initial embodiment. So this is, you need to know the cache size tu berapa. What is the dimension here? What is dia punya height dia? What is the length and width? Okay, this is the kandang. Betul tak kelas? Hello?
Yes, betul.
Bila dapat layout plan, you tahu the size. Bila you tahu size, then you know where to which to put your punya system. Betul tak? Betul tak guys? Kalau layout plan tak macam mana kau nak buat, saya pun tak apa benda. Macam mana kau nak buat design korang? Kau punya design kan ada feeder, ada distributor, ada opening, ada conveying, right? Conveying, distributor, betul tak? Final concept, am I right?
Betul.
So kalau kau tak ada, mesti ada layout plan, give dimension. Then you know, okay, why you discuss dulu, you buat sketching. One of you or five of you buat sketching, macam mana you conduct online, sketching, okay, layout plan must be there, how you mount you punya system. Okay, where is the location of you punya ni? Because I believe ni sebenarnya already done sebenarnya. Betul tak? You punya final concept tak kan? Final concept from your geometric already have some basic sketch, betul tak? Betul tak?
Betul.
The champion kan dia already provide sketch. Use that sketch, the sketch, the champion or maybe you combine ideas, you make a sketch or you resketch balik. If you combine ideas, the result from your second geometric, you combine ideas or you make a resketch. Okay, the first sketch has to be in assembly mode. Have to be in assembly. Okay, you must, syarat ni you mesti ada the layout plan dimension, mesti ada how you mount. So the location of your tank feeder. What is, okay, you have the, what is the size of your feeder? The overall, not the detailed dimension. You punya feeder, the tank. The tank tu apa dia punya size dia berapa, ini berapa dia punya dimension dia berapa, location dia kat mana. Coordinate positioning in the cage, betul tak? Betul tak guys? Betul tak? Hello?
Betul.
Then okay, this is you punya tangki. Maybe I don't know you punya file concept, it could be a cylindrical shape, maybe it's a box shape feeder or maybe a hopper shape, it's up to you. Tapi you have to identify juga, okay, this is the feeder. This now at this moment you can identify which part. So you kena develop more. Identify, okay, feeder, what is feeder type, apa name of the feeder, name it, and kemudian material, what material feeder. Material ni you just select material based on standard lah. Only yang crucial part, yang critical part, yang you ada technique, I share you the video, how you select the material. You have to be proper selection of the one. Okay, the tank, position, the where, dimension, basic dimension, the position. This is assembly mode, not exploded. Okay, then kemudian you have zone B, the opening lah, maybe, okay. Maybe you have opening at the bottom. Ini yang opener lah. Okay, ini yang focus on the ni. So you kena label kan this thing tau. Ini one, component one. So, in your sketch, Nampak tak my sketching? Your sketching is there. Nampak sketching saya ni. Sketching saya ni is not terbalik Tadi
Nampak.
bila ada sketching dia flip betul
Betul Datuk, betul Datuk.
Okay, ada sketching tu you ada BOM, tahu tak BOM? Bill of material, tahu kan?
Tahu Datuk.
Bill of material. Bill of material, because bill of material is important. This is really important. You have bill of material of not number of component, the name of you punya component or part, and you punya material. Okay? Material and the quantity lah. Quantity team sometimes ada benda yang duplicate kan, dia more than one. Same component, more than one. Okay, number one. Okay, this is component one. Feeder. This is feeder. Material dia apa? Ini tak payahlah. This one you don't have to follow. Nanti I will share you a video. Ada cara yang crucial part only yang involved dengan loading, sustain load. It's a critical part. That one you have to see really important, really very ni lah. Have to be accurate to select the material. Have to be really careful to select the material. Yang macam feeder ni tak perlu lah. Feeder just continue use. Tengoklah the one. Tapi be careful. You must obey the what is requirement from the PDS. PDS under heading material ada mention that all the material component can withstand corrosion kan, because you involve your feeder involved with what food you want to contain. It's a cow food, tengok the condition cow food, so your feeder to have to be really kind like a standard lah for that one. That cannot easily corrode can withstand corrosion cannot get rusted, and itulah they don't have chemical effect. These all the statement that already stated in your PDS under material. It's there already. Make sure your PDS tu yang detail lah. I need to check nanti your PDS. You must obey the PDS material part that you introduce, the size that you introduce, must obey all the requirements that we set. Because your PDS also ada mention about heading size, the size of your overall system. Make sure that you obey all the requirements set in PDS. That's the idea of this embodiment design. Feeder, then you have the opener. They have the opener sini. Ni nombor 2. Opener, I don't know, I'm not sure whether I'm doing right lah. Ini contoh lah, example lah. Maybe. Opener material. Ni feeder material apa? You cakap, I don't know, I'm not sure this right or not. You can use steel can get easy corrosion, rusted kan. Material dia apa, for feeder. You kena check lah, because your PDS already stated what material for ni. That's why itu dalam standard ada pun legislation cakap you ada mention if you done any legislation on cow handling, ada mention for the cow handling device what material to select. Opener apa material dia. Then you have conveyor you macam mana shape. Conveyor have to be detail. Okay, ini conveyor. Ini rough rough conveyor. Ini BOM of assembly rough mode. What is the material? Ini quantity 1, ini quantity 1, maybe 2, maybe one of the group maybe doing ada symmetrical lah, 2 row kan, 2 row. Cakap 2 kan, 2 row. 2 lah, feeder 2, feeder 1, ini also 1. Feeder ada 2. Kan, you ada left and right row pasal you ada partition. Okay, ni you ada distributor, you ada partition lah. Ini conveyor, 3 is conveyor. Nampak dia ada penunjuk, dia ada labeling bentuk number and 4 you have how you distribute conveyor how you distribute macam ni the start of this conveyor is the shape, and how you punya system one, or you focus on sketching on distributor. What is the mechanism when you conveyor, how you distribute the food. This one is for distributor. Understand guys? Apa material, quantity berapa. Faham tak kelas? Are you with me or not?
Ya, faham Datuk.
Yes.
You buat detail like that. Ini full assembly dulu. Ini full one sketch of full assembly. Ada nombor of component, ada BOM lah. Itu rough. This BOM yang rough BOM. Under kategori lah. Lepas distributor apa? Remover accessory food remover, something like that. Betul tak?
Betul.
Remove, I don't know how you name it. Remover, food remover yang accessory food. Excessive food remover. Apa material? Where is a food remover yang lebih jatuh ni? Apa sistem you pakai, you sketch ni. Itulah, this full assembly dulu. You make this one the full assembly. The dimension also of the layout plan, the size of your cage and basic dimension of your size of your tank and the length of your, also the length of your conveyor, the width, the overall size lah, not detail. Okay, this one your punya subsystem intact. This sketching yang full assembly, everything in assembly mode. Assembly mode. Clear? This one clear? Faham? Ada question tak tadi? This is your first sketch. Ada question tak? Detail. I show you ni not proper, not detail. You have to be detailed enough. Boleh? One sketch on this. Plus. Boleh buat ni?
Boleh Doktor. Doktor, untuk yang sketch pertama ni kena ada complete semua Doktor ya?
Complete semua. Tak, kalau A1 lagi batu A3 ni tak.
Kalau tak nak A3 dan nak A1 boleh Doktor, saya nak.
Ya. That's my point. Yes.
Okay,
tapi show saya PDF je lah kan. Itulah dia.
Doktor, untuk yang pelan ladang tu, Encik Gadis kata dia tak ada pelan Doktor.
Habis tu macam mana?
Dia kata suruh datang
macam mana? Dia tak ada pelan, kau nak buat macam mana?
Tu lah sebab dia kata banyak dokumen dia dah lost, dia kata.
Habis tu macam mana kau nak make things happen? Habis takkan kau main agak-agak, tak boleh. You cannot just guess je. You kena ada overall layout plan. You have to need the dimension. Takkan tak boleh cakap dia punya kandang dia tak ada dimension ke?
Itulah sebab dia suruh kita orang datang ukur sendiri.
Habis kau boleh ukur sendiri ke?
Tu tak pasti tu.
Dia masa kau datang itu kau tak buat kan? Saya lupa nak beritahu. Macam mana Ada idea yang lain? Any idea? Bahaya tau, bahaya This could very dangerous kalau you just main guess saja, tak boleh. Pasal I want you to work as a professional. Professional tak boleh macam ni. You got to push him lah.
Kalau minta pihak dia untuk ukur Doktor?
Itulah. Kau punya, macam mana kau punya effort lah to ask them, push them to ukur. Kalau korang boleh datang, bolehlah, cuba datang lah. Tapi kalau boleh, kita we are working for them kan. Takkanlah dia tak ada dokumen benda tu. They don't have drawing. What about the other group, the other session, kelas lain ada tak? Dapat apa-apa? Korang ada group WhatsApp apa-apa tak yang ada sarjana field?
Ada. Dia sebab Cik Kadir tadi balas dalam tu. Dia kata tak ada.
Tapi pun kelas lain pun macam mana dia nak buat kan? Kalau korang punya sistem nak mounted dekat cage, betul kan? Betul tak korang punya final concept? Your final concept, betul tak?
Betul.
Nak mounted, you want to mount, you want to fit your punya system on dia punya, what is your boundary? You have to know the boundary. Kalau tak ada boundary macam mana? You punya cage itulah. You punya surrounding itulah. Macam mana kita nak guess tu? Dia punya size of the kandang cage. At the moment dia punya lembu dia ada in cage, ada dalam dia punya partition tak? Tak ada. Currently in the cage.
Bebas
no partition.
Dia bebas dalam cage tu. Tak ada partition untuk satu ekor.
Yeah, okay, maybe your final concept maybe you introduce partition lah kan. Maybe you punya your system that you tidak ada, tapi you mesti ada dia punya dimension of dia punya overall tu. Ni kalau tak katakanlah kalau katakan let's say lah you cannot get it, can you get any standard cage punya from internet? Ini your project guys, you have to make an effort. Immediately. You can immediately dapat ni mana-mana yang cage punya layout plan yang as a standard can be implement. Kalau tapi kita preferably ask dulu Encik Kadir, do you have it? Kalau dah memang itu the answer they don't have it, okay tak apalah nak buat macam mana. So you have to find from Felda ke from any yang from the internet lah. Kalau you go for New Zealand or something, it could be, I don't know, maybe their system is quite different than ours, how we handling the cow, I'm not sure. Maybe dia punya cage, they are more advanced, maybe Netherlands for example. Maybe they have a standard cage punya design. If I'm not mistaken, they have partition. Macam you say yang sarjana female dia akan have partition. Okay, let's say your punya final concept you have partition. So okay, my point is, can you get the dimension of your boundary lah you punya ni? Boleh dapat? Get it immediately. And this standard cache. Boleh guys? Kalau tak ada tu, you tak boleh buat sketching ni. You tak boleh buat initial embodiment design ni. Mesti ada. Boleh kelas? Okay, buat benda je. Dapatkan macam mana cara je lah you boleh dapat. Okay? Kalau tak dapat daripada sarjana female, you try to get from somewhere internet. Ikut standard. Make sure you punya size of the cache ni yang proper guys. Standard one. Berapa the size of the ceiling from the to the ground floor. What type of roof they use. Roof dia macam mana. They have ceiling or not? They have ceiling or not? The ceiling tu. Macam mana? What is the ceiling? Ceiling tu macam mana?
Ceiling dia tak ada.
Dia tak ada no ceiling kan? Okay. So, you need to know the condition of you punya ni and also the dimension of it. Tak boleh dapat daripada dia, you try to design your own. Boleh? Okay, you already visited the place. They don't have ceiling kan? They only have roof kan? No ceiling. Okay, you design the structure. Faham tak sini? Dia tak ada ceiling. Guys, can you see my video tak? Ada technical error ke apa ni?
Boleh doktor.
Okay.
Nanti kau buat macam ni tau. Okay, let's say ni layout plan. Saya believe dia bumbung je kan, only roof, right? Plus. Can you see my sketching? Nampak tak?
Nampak doktor.
Pasal korang ni ada boom kan? Ada boom structure, betul tak kan? Ada beam kan? Hello? How you introduce? Your final concept tak? You have to specify all the part that you introduce. You want to mount on you punya ni. Ada boom sini, ada apa ni, very long beam where you want to mount you punya, where you want to fit you punya mount you punya feeder. Okay, the boom that okay, kena letak sini komponen ni. Ni komponen ni apa nama dia? I didn't mention. Boom is not the right word. We call it yang the beam lah, beam. Horizontal beam. Ni komponen nombor berapa? Nombor 5, nombor 6, horizontal beam. Understand tak? Ada 2, how many? And also you ada cross member beam, betul tak kan? Ada cross member where you mount. You want to mount, you punya, katakan your feeder tu mounted on the ceiling. You kena introduce ni dalam sketch. Faham kelas? Yang penting dapat layout dulu size macam, okay, I believe dia punya bumbung like that. They don't have ceiling, right? Betul kan? Just bumbung only. Just only roof, no ceiling. So you have to design the beam. Pasal guys, you are fourth year, betul tak guys? You know what component is it kan? Boleh tak sketch benda ni? Komponen apa ni? Kalau ikut standard kita pakai apa?
Boleh doktor, insyaAllah.
Horizontal beam you design on ke you order from the hardware? I want to ask you guys. What beam you use? You are already fourth year guys. Apa beam kita pakai? Box section ke, C channel ke, I section? This is your knowledge. You are group of 5. You already nak graduate fourth year. You have to know. Understand tak? Beam. Are you using wood beam ke steel beam? Construction steel beam. Itu you kena decide. Nampak tak? You kena condition. Kalau dia punya cage is a concrete structure kan, dia punya wall, dia punya tiang. Tengok what type of beam that you rasa is suitable to be mount on their system. Normally kalau you punya system kita rarely kita tak use wood kan. We not design housing structure house. We are talking about metal beam. It must be metal beam. Tapi metal beam ni what type of beam so one of you have to check what if construction metal beam can be used as you punya beam to support you punya system lah. Because this is a component that you introduce to be mount. Itulah saya cakap mesti tahu layout plan dia, dapat secepat mungkin lah. Kalau boleh you use the standard that you can get from internet. Okay, then itulah dia. First sketch ni faham ada itu first sketch macam ni boleh kelas. Mestilah tahu all the rough component, distributor. Boleh, ini first sketch. A1 better lah. Smallest A3 lah. Okay, ini first sketch. Okay, second sketch. Ni yang second sketch ni yang delegate group each team member kena sketch. Second sketch mean, okay, first you have assemble kan. Okay, one of you yang focus on feeder. Okay, feeder attached to the beam. Betul tak? Ras. Feeder attached. Siapa yang
Betul.
responsible for feeder buat ini yang nama explore. Explorative scale, you explore. Yang ni example. Example pun kind like kita example, we identify component. Ada BOM, remember? BOM must be there. Ini pun one of you yang fokus on feeder tadi. Feeder punya. One of you yang fokus on feeder. Tapi feeder connected to the beam tau. Feeder and beam together. Pasal you tak boleh cakap you focus on feeder saja. Tapi siapa who is doing detail of the beam? The boom structure yang you mounted. Siapa yang involved? Dia connected next to the feeder, betul tak? Right, betul tak? Contohnya, ini contoh saya. Korang punya can be different concept. I don't have any idea. Saya tak tahu your final concept yet. Okay, contoh kalau saya ambil objek. So, yang buat feeder tu, ni feeder punya ni lah. Feeder exploded. Ni exploded. Ini maksud dia exploded drawing lah. Exploded. Atau you, maybe you boleh buat assembly exploded, you also can provide version of sketching pun boleh. Tapi okay, ini yang focus on beam, you buat, you ada beam, katakan you pakai, not necessary to be box, C channel also is quite C channel, you kena C channel, ada boom structure. Ni you can make it exploded version. I already asked you, ni semua dalam isometric or perspective, I already explain to you perspective sketching, right kan? Draw properly lah. Okay, you namakan ni beam. Okay, dan kemudian how you have ada cross member kan. You can make exploded version mode. Cross member ni biasanya is a box section. It depends on how you decide. Or C channel also can. Box section. Ini pun material. Ini pun ada BOM lah guys. Nampak ni? BOM kat bawah. Okay, syaratnya saya cakap, okay. Now ini yang individual punya sketching. Individual sketching ni class, pay attention. Every single pieces of component must be included. Even single screw pun mesti included. Pasal ini you focus on yours. Concentrate on feeder and the punya beam structure. So how your feeder connected? For example, you have feeder bawah tu, okay, you buat exploded version is good lah. Rather than assembly, you tak nampak komponen kan? Okay, you punya ada feeder. How is, okay, this beam ni, okay, sorry, before feeder, this beam how you mounted on the, kalau saya tengok full assembly ni, you beam saya cakap mounted on the punya structure of the kandang tu kan, of the cage kan dia ada, betul lah cakap, you kena, kalau dia bagi, you tahu, sekarang ni problem dia tak bagi, tapi you kena design your own lah. Kalau tak dapat daripada Encik Kari, you design. Dia punya dinding dia macam mana, concrete or what? Bila you visit, kan you already visited, what is the dinding? Dinding kayu ke apa ni?
Dia tak ada dinding.
Tak ada dinding pula, dia tiang aja.
Dia tiang.
You boleh memorize kan tak? Boleh you memorize in your kepala. Pasal kalau ada layout plan dah ada dah listing, no problem. Katakan tak ada. Dia tiang saja. So this all tiang. So make sure tiang sajalah. Rasa the structure of the cage kandang tu. Okay, maksud saya yang you punya sketching on ni, how you mount on the tiang, make sure ni ada tiang kan. Tiang is not part of it, tapi ini boom ni akan mount pada tiang, betul tak kan? Ini ada tiang, betul kan? It's a column. Ini also have column, betul tak? I don't know, betul tak? Ini, yang ni ada dua. Yang ini mungkin mounted on the column, I don't know. Ini kita tak ada column. Maybe, what is the boundary, your boundary there? Understand what I mean, kelas? Faham tak? Tapi okay, kalau dia if it is mounted, the boom is mounted on the cage, you cannot leave it. Apa sebab your sketch ni have to be detailed guys. You tak boleh cakap okay ni attach to the tiang. How do you attach it? Nampak my sketching. How do you attach this thing? How do you attach this tiang? Kalau you as engineer, apa you attach kat column? Ni concrete column. Ini you punya boom. How do you attach this beam to the ni? Kita tak boleh cakap je macam ni next. Okay, this one attach, tak boleh. You kena cakap how do you attach it? Pakai apa tu?
By bracket ke?
Yes, bracket kan. How you design the bracket? Okay, I make it bigger. Bracket macam mana? Bracket macam ni lah. You have sketch. That's why you have to be detailed. You sketch kena tunjuk ni. You punya, okay, yang ni tadi cakap, you punya C channel kan. Ni part of your C channel. Okay, I saw part of the sketch. C-channel kan? C-channel. Katakan you pakai C-channel to attach to the concrete. Okay, you kena tunjuk sikit itu concrete. How do you mount to the concrete? You kena pakai bracket. So how do you design the bracket? You ada C-channel, jadi ada tebal lah kan? Tebal macam mana nak mount dekat tu? Tu you kena design that one. Macam mana design the bracket? How to design the bracket attached to the concrete? So you kena buat some kind of macam mana kita design the bracket yang ni tu.
Bentuk L kot.
Dia mesti betul, you're right. Dia mesti ada L bracket kan, betul kan? So dia mesti ada L bracket like this. L bracket like this. Betul tak? Betul tak guys? Are you with me or not? L bracket. Ini part yang your custom design. Ni you introduce. Betul tak? Plus.
Betul.
L bracket. Ini okay, how this attach to this L bracket? The beam L bracket ni apa? Normally apa? Kita ni. Welded lah kan? Tak kan? Ni kena mention welded. Faham tak kan? Contohlah kalau saya welded lah. Kalau you nak buat screw macam mana pasal ni? Ini welded lah. Ini welded to ni. Ni L bracket dekat this one. You put dalam, everything put dalam ni lah. Dalam BOM tu mesti ada. Faham tak? L bracket. Understand tak guys? Kelas? For you yang focus on the feeder. For example lah, feeder pasal ini bracket ni connected to your feeder. Okay, this bracket ni how do you mount on this concrete column? Okay apa? Okay, kalau you attach dengan column tu macam ni lah. Okay, jadi concrete column tu sini ya. Okay, this is a concrete column. Concrete column, betul tak? Do you understand my sketching ni? Nampak tak? Faham? Okay, how this bracket mounted on the concrete column? Pakai apa?
Pakai apa? Bolt and
concrete bolt. Nah, tak payahlah. Concrete bolt, dia bolt terus lah.
Bolt lah.
Ni concrete bolt lah. Ni ada kind of bolt. Ada tifak bolt juga Bolt and berapa. Ni pun ada kena identify. Nampak tak? Dalam bill of material tu nombor berapa? Nombor 7. Pasal saya cakap ini bolt kan. You cakap, you tak payah mesti kat sini. Ni level tahu balloon kan? Ni komponen nombor 8. Tahu kan balloon? Tahu kan buat ni drawing kan, ni sketching. Balloon, penunjuk. Ini beam. Ni komponen nombor 7. Ini komponen nombor 6 for example. Jadi ada nombor 6 di dan BM. Di material dia apa? Ini tak payah. Ini beam you boleh cakap steel je lah. Quantity dia berapa? Pasal dia ada 2 beam. Quantity ini material. Ni nombor. Faham Jadi kau buat detail. Lepas tu ini quantity. Ada 2 beam. Lepas tu nombor 7 bracket. Nombor 7 L bracket. Steel. Berapa kolom lah? Kalau ada 2 kolom, 2 kolom, satu. Contoh ada 2 lah. Ada satu side sebelah sana kan? Satu side sana, satu side. Dia ada end. Tak itu lah. Tahu buat Lepas tu ada bolt and nut. Nampak tak guys? Hello? Bolt and nut ni. Bolt saja. Nut tak ada. 4 bolt. Dia ada 8 bolt. 1, 2, 3, 4. You cakap yang ni komponen nombor 8 bolt. Okay, you ada box sini 8. Bolt apa? Bolt M berapa? Tak payah sekarang at this moment you tak tahu M berapa. You cakap bolt kan? Steel berapa? Ada 8. Contoh macam tu detail. Okay, ni vertical beam. Dan kemudian ini you punya. Okay, maybe you yang fokus yang buat on the feeder you have to visualize. Maybe yang zoom in. Maybe you have yang overall view of you punya feeder. And how does this feeder connected to this thing, to this cross member ni? You buat kind of exploded. How this connect? Pasal this thing, ini yang cakap you punya at this stage initial embodiment design, your sketching ni have to be proper guys. Kalau you tak buat, you tak identify all the component involved, you will have full face problem nanti. bila you nak buat fabricating, you tak know which is which. You tak identify pasal ada komponen tu, you just roughly guess on your final concept pun, you just rough buat ini, you don't know what is question. No such thing component like feeder ni, tangki ni floating in the air, must be supported. You have to mount on the cross member. How you mount it? Under screw, bolt or nut, or maybe you have kind like ada dia kind like snap feed. Maybe they have kind like dia ada kind like ada bracket tepi on the feeder can be slot in like that. Dia ada bracket, air bracket, dia akan slot masuk situ. Faham tak kelas? Have to be in detail. My point is to be detail. Boleh?
Boleh Doktor.
Boleh. Lepas tu feeder ni pun, feeder ni komponen nombor 1 tadilah yang beam modul. Semua ada dalam BOM lah tadi. Okay? Have to be in detail lah. No such thing component yang floating in the air. Must be spotted. Component within the next component next to each other, no such thing is just next to each other. You tak boleh buat komponen macam you punya sketching. Maybe you have a component, this component dengan this component like that you buat exploded. How does it connect within here? Is it by screw? Is it by welded? Is it by snap feed? Kena identify. Pasal now you are forced here, you already know what mechanical component to join all the part lah. What all jointed dia punya ni lah component use to join component to each other. Is it kalau welded, you mention the welded. Kalau you mention you using screw, using screw pun. If you have bracket, using bracket to connect each other, what type of bracket? Macam tadi lah, ni ada bracket kan. So connected to the beam, you need bracket. So identify. Macam tu lah. Yang ni welded to the bracket. This one welded to bracket and this bracket bolt to the concrete. Okay? Kena proper guys, kena detail. I cakap you have to do this. Kena buat. That's why pasal you punya system ni very big one kan. You have conveyor, tak, you have focus. One per team member doing focus on this. Focus on feeder. Boleh tak? Kita guys, boleh buat saya cakap ni. You understand ni? Boleh buat tak sketching?
Sure.
Yang individual. Seorang on feeder, lepas tu lepas feeder you have ada opener pula kan. Seorang doing opener. Okay, yang doing opener. Okay, yang tadi feeder tadi pun saya buat ni tak detail ni. Ada detail lah sketch. Apa connected. Every ni ada level of component. You kena letak kat sini nombor komponen, name, material and quantity. Boleh Detail. Kena detail. Kena detail. Banyak, you ada lot of component sini. You ada component involved. Ni lot of thing. You feeder. Okay, your feeder ni, kalau you buat feeder, you mesti ada opening kan Okay, opening tu, you have opening. Okay, one of you on opening part, distribute, how do you ni? Opening, maybe feeder together with opening. Together with opening. So opening, you have some, okay, you have some tube sini lah. Okay, just this example lah. Ini I didn't say, this is your concept. This I roughly guess. Okay, this is a tube. You mesti ada opening bawah kan. The opening and this opening cannot, okay, this you have a box. You have a metal box like this kan. Okay, metal sheet as a box sheet. Okay, ini nama ni komponen nombor berapa. Letak kat sini dia komponen. Ikut order guys. Faham tak? BOM ikut order guys. Hello class. Are you listening or not?
Ya Doktor.
BOM ikut order tak? Ikut order. Every itu. Okay, maybe you have another yang zoom in version. Maybe they from this BOM, the same BOM, you have a view what dia punya number dia. Okay. Macam mana this opening dengan the hole, how you join it? You cannot, is it welded? Okay, you have a bracket kat sini, you design, it will be screw. Okay, you punya component metal sheet tadi, ini will be, pasal kita ini tak boleh fully welded. Kalau machine get stuck, kita can easily open kan. Ni screw, kalau screw you introduce screw, mesti the screw also must be included. You screw and nut kan, screw and nut pada tu. Okay, you ada bolt and nut. Kalau you screw, mesti ada nut from the inside lah, the close. Atau maybe you pakai snap feed. Depend macam mana. So every yang ini nut also mesti ada ni, mesti ada dalam BOM. Clear tak guys?
Clear Doktor.
Okay, ni okay. I think feeder dengan opening mungkin one. Okay, one of you focus on the bila dah jatuh pada, kalau kita tengok kita ada contoh saya ni lah, dia ada conveyor. One of you doing sketch on the conveyor pula. Katalah conveyor you bentuk semi-cylindrical for example lah. The sketch on this. sketch tak perlu cantik guys, tapi as long representable lah. Faham maksud saya Okay. Conveyor. No such thing conveyor floating in the air. That's my point. Tak boleh dia floating. Conveyor ni nak support by apa? Sebenarnya dalam full assembly pun ada mention ni. Conveyor ni tak floating, dia ada structure. You kena draw sini. Kan? Betul lah guys? Ada supporting structure for the conveyor. Betul tak?
Betul.
Jadi you kena ni lah. Okay, ni you buat exploded conveyor. Conveyor the food. Ini from the opener you cakap From contohlah opener tu. Food dah tu, ini bring the food So no such thing conveyor floating in the air. The conveyor must be supported by supporting structure. You mesti ada how you design that structure tu ni. Conveyor ni okay, kata what type of conveyor. Kalau you can get conveyor yang standard part is good If you tengok dalam internet, dalam Amazon ke, Alibaba ke, dia banyak industrial component on conveying, you check apa kita cakap ni, conveying material, material handling conveying metal, apa you type. You can type from Google or Alibaba, you can check. Dia ada type of conveying yang bentuk cylindrical ke. You can, from there you can see the diagram, you can see the, you don't have to detail like in the internet, in the diagram, you can rough idea lah, conveying part macam mana dia, how dia stand kan this conveying. Maybe you design dia ada kind like dia ada shoulder dia kan, the shoulder have to be proper sketch kan. So how you mount, then you punya supporting structure tu macam mana, how you punya supporting legs you design. Itulah kena proper lah cakap you, benda ni tak boleh elak ni, kena pasal you punya design, kena design lah supporting leg tu macam mana. This supporting leg ni apa type of leg yang you pakai to support the conveyor. Then you have a beam sini. Tak, it means before you do proper sketching ni, you kena sketch dulu and for lah, how you design the supporting leg. Maybe you can get from internet lah dia punya supporting leg. Macam mana kita design to mount the you punya conveyor to apa, as a supporting structure for your conveyor. Kalau macam ni dia tak tegur kan, so how many leg that you need. Okay, kalau you tak boleh letak cross member kat sini pasal you want to mount the conveyor, so how you design supaya dia keep stiff dia rigid. The leg tu, how you design the leg tu macam mana. Maybe you buat construction terus ada kaki macam apa, ada kind of structure like this ke, semua ada cross member kat bawah ke, or maybe kalau you can make it, dia ada cross member. Kalau you cannot put cross member, kalau you ada cross member macam ni, you tak boleh mount you punya conveyor. So dia mungkin you conveyor, okay, conveyor have to be mount on top gitu. So you punya supporting leg ni have to be ada cross member, have to be rigid enough lah. Yang ini dia kena rigid lah, dia ada cross member macam ni, cross je ni ke. How you design dia punya structure tu lah, dia punya leg. Okay, dia rangka macam tu. So my point is, so lah you kena proper kat sini. Boleh kelas. Yang conveyor tu, okay, conveyor tu how do you move it? How do you move? Dalam you punya final concept, you punya system from your, how is the mechanism that convey the food? Kalau you pakai flat bed conveyor, so kalau katakan you punya design you pakai flat bed conveyor, so you don't need to do detail sketching lah. As long katakan you order this conveyor. Katakan your conveyor tu you order from the you get from the internet. They have a standard conveyor. Okay, design ni bukan not everything we design on our own. Okay, kadang-kadang we have to play smart. Sometimes kita tengok whatever current apa ni supplier already there. Kalau kita design our own flat bed conveyor, it can be more costly, more expensive. It can be more costly compared to we order standard. Because when they have standard part, they sell cheaper. Because they have there is already a supplier, vendors that do manufacture flat bed conveyor. So we just simply order flat bed saja. Kita tak perlu design our own. So you tengok based on internet diagram, you draw lah. So the flat bed conveyor, they come up with supporting structure. Dia together. Kalau the supplier that sell the flat bed conveyor, they have a lot of roller ni. Of course, they have the supporting structure dia lah. Okay, kalau ni you mention lah, kalau you use flat bed conveyor lah. Tapi I don't know what is your final concept, because something maybe in your final idea you don't have to be costly. Kalau sometimes when you, my point also, kalau you order flatbed, everything part you order saja. Maybe at the end also it could be costly juga, could be expensive pasal semua we have to buy this part. Katakan you have this flatbed conveyor. I'm talking kalau flatbed conveyor you order standard part. Kalau you design your own conveyor, like macam ini, like C channel like this you design, you cannot find anywhere in the industry, in the market, they don't have, maybe you design your own ni, tetapi you have to think of what is the mechanism you want to convey the food. Itu you punya system, itu yang based on your final concept lah. So in your sketch able to tell the mechanism, not just the part, the mechanism that you use, how you convey. This is just a channel, but how you convey, you distribute the food. If you have a channel, I don't know, that's your final concept lah, apa mechanism yang dipakai. Understand class? So you punya sketching ni kena detail and plus BOM lah. When I'm talking about other BOM, mesti ada BOM, mesti ada table BM. Detail. Kalau yang di inverse single piece screw pun kena ada tipai. Boleh tak class? You understand what I'm talking about? Faham? Class?
Faham.
I give you 1 week on doing this. Maybe next week tak ada kelas. Bukan next week ada kelas lah. This coming tu tak ada kelas. Pasal design macam ni. Pasal ni memang busy moment. Memang at this moment after semester memang busy moment. Memang kalau face to face pun kita short meeting. Kadang-kadang I cancel the second meeting. Tapi the first meeting I got to brief you guys. Pasal you need to prepare this. Boleh? Ini individual. Team member. Each team member kena involve. Seorang buat sketching on the either this thing, seorang on the conveying, or I think feeder dengan opener together lah, opener. And seorang on the conveying tu detail. You faham tak guys? I cakap sketching ni kena detail. You understand what I mean? You clear or not? Faham tak maksud saya? Every single screw, no such thing component floating in the air. Macam this conveyor no floating, ada floating saja. Kalau you punya part is from standard, you using flatbed conveyor, you have to draw a little bit lah. You cakap what standard part, they already provide you. So you don't have to be detailed. Tapi you punya custom design, katakan using just a channel, no floating in the air. Ini I just showing you just only the supporting structure. You make some sketch the leg, identify the part, put the BM watch number component, how you join here and here. And tapi I didn't show you in my sketch ni how the mechanism work. Pasal is no idea, this is your design. I don't know what is your mechanism that you use to push the food to distribute to the equally distributor. Okay, in your sketch ni ada distributor tadi saya cakap kan, distributor. Okay, yang nombor 2 tadi buat conveying, nombor 3 student do the distributor. How do you distribute? So yang number 3 student have to provide sketch yang kena communicate dengan orang doing. You have to communicate with your team member doing the conveyor. The conveyor have to be communicate with the person who doing sketching on the feeder and the opener. The tally you got to tally. Kalau tidak you tak tally, problem. Bila you want to integrate, bila example tak tally, problem juga. That's why kena communicate. Orang kena discuss dengan group. Okay, yang opener, lepas tu ada distributor. Distributor kalau tengok full assembly pun kena buat guys. Remember I cakap tadi, full assembly ni seorang kena buat. Plus, clear not?
Clear tu.
Full assembly seorang buat feeder dengan opener, satu conveyor. Masing-masing ada BOM masing-masing tau. Faham tak? Ikut subsystem. Faham tak? Ada BOM masing-masing. Lepas tu distributor, kalau tengok full assembly, after conveyor, how distribute the food? Saya tak tahulah, your conveyor tadi, is it moving or just put under container? Mungkin you buat the slanting, I don't know, you punya konsep lah, the slanting memang dia ada, tapi benda ni wet food. Kalau wet food, I don't think, kalau you buat gravity based on slanting conveyor, I don't think so, it will flow down. Maybe you use shaking mechanism kan, from the opener, from the feeder. Pasal katakan you have just a simple channel, so you don't have to buy flatbed conveyor. Flatbed conveyor is very expensive. Or screw feeder also good, very efficient, or distribute the food equally, but it's quite expensive. Katakan you just a simple channel, tetapi the channel tu kalau you make it slanting, tetapi to distribute the food, because it's kind of wet food lah, dia bercampur dengan rumput kan. What you call it, you punya food tu is the, apa benda food dia? Food dia bentuk apa? Kelas food dia apa? Food. Kalau kelas, orang yang do the research, come on, the food tu what type of food? Food dia material dia apa? Condition dia? Apa dia punya form and shape, the food? What kind of food dia tu? Is it granular or is it wet food, macam mana tu? Campuran the apa? From apa? Ubi kayu, jagung, ampas jagung, apa ni? Plus, are you listening or not? I'm asking you.
Yes, betul.
Food dia macam mana condition dia? What type of food? Kau food? Rumput ke apa?
Potong halus.
Campur apa? Plus,
Campur dengan nanas.
dia bentuk apa? Dia kind like the hancur ke? It kind already
Hancur
blended
betul.
or okay, maybe one of you already blended kan? Maybe you punya concept blended. So dia dalam keadaan kind like sticky kan? Okay, my point, the food gets sticky. When you open from there, you don't think, you got to make sure that from the tank tu, your food tu will get stuck from the tank tu. Your opener tadi, I'm talking about opener tu. Opener to have kind like, your tank to have kind like shaking mechanism. Rasa macam mana? Yang tadi. Dalam your sketching tu kena provide me. Dalam your sketching you kena explain juga yang apa tadi? Yang container tadi, yang feeder tadi. Mana pula sketching? Ini dia punya beam, mana tadi sketching? Ada container, kita tak show. Kita tak buat sketching on container. Okay, ini bawa. Okay, you punya tadi yang buat feeder tu. You punya opening, you punya food ni, I think ini saya rough saja, you punya bentuk dia tak doesn't mean box, maybe hopper lah, you punya feeder tu have to be. Guys, saya ni just mumbling about the concept, maybe your concept different, much better than me. You punya, I think you punya feeder must, you punya shape of you punya feeder mesti hopper lah, if I'm not mistaken. Kalau you buat box section, kalau you open, do you think you punya food tu akan apa, will be pull, apa, will go down? You think you no, I don't think so. Pasal you punya food like kind like sticky, dia irregular punya shape condition dia. It may be sticky, maybe dry, mixed condition. So I think you must have your feeder ni mesti ada kind like shaking mechanism lah. So you introduce you punya shaking mechanism to make sure that the food will be dumped out into this opening. Understand tak, guys? You know what I'm talking about? You mesti ada, kalau you flat macam ni, I don't think so. Dan you mesti bentuk hopper shape. You katakan you design macam tu. You must have ada shaking mechanism. Either forward movement or left and right movement. So you introduce your shaking mechanism ni mesti ada dalam your punya component sini. So this is my talking only. I don't know your concept because I haven't seen your concept. Normally kalau group dia present to me their final concept, then I can make a comment to dia, for example then only they can throw the food into this channel, then this channel they go to the apa tadi, the C channel. Ni yang opener. Okay, I'm talking about the C channel. Kalau you make C channel, kalau you buat the horizontal flat macam tu, dia takkan distribute, dia takkan flow. Kalau you buat dia slanting like this, okay, this front view lah, you punya channel tu at an angle, ada theta ni. Okay, you punya food dah jatuh sini. You want to buat channel and kemudian the channel kemudian they will distribute lah. Tetapi you want to make a flow pun, the channel ni can get stuck lah. So, ini pun kena shaking mechanism, betul tak guys? Ada shaking mechanism. Ini contoh kalau your concept is, betul tak? Kalau you just a simple channel, you need some shaking mechanism tu, dia akan jatuh. I don't know, is your creative, how you punya final design, I don't know macam mana. So that's why I need you to present to me by next week, you punya final concept juga. Maybe kita can modify some little bit. Sometimes I can make comment whether it works or not based on my experience. Understand kan? So I'm talking about how you convey the channel. Kemudian you need, okay, the other student will, the distributor also have to make sketching how you distribute the food. Okay, maybe distribute the food tu yang critical distribute. Okay, katakan you have channel. Okay, katakan you have 3 channel. Yang distributor tu are thinking about how you convey and distribute. Ni distributor lah. The student will focus on distributor, focus on the mechanism. Maybe I think benda ni you already discussed during your evaluation concept, betul tak During master evaluation already discussed. You know what mechanism you're going to use. It's already there. This I'm just mumbling lah. If I haven't seen your final concept yet. You know already the system. Okay, distributor have to make proper sketching the detail. Understand class? No such thing component floating. You have mechanism how you distribute. You make a proper sketch. Class, faham class? Clear or not? Class, are you clear or not?
Clear Dr.
Detail sketching, distributor kan detail. No such thing component. Every single piece, screw, spring, kalau bearing ada, macam for example you have shaft. Katakanlah your component have shaft kan. This is a shaft. No such thing shaft. Okay, shaft cakap dia ada bearing. Okay, shaft ni mount on what? Shaft, okay, bearing mount on shaft. Okay, this bearing mount on what? Bearing kan dia ada bracket kan. Mount on what? Bearing mesti ada frame dia. Kan, betul tak? Understand tak? Understand tak guys? Macam your machine component design your project, kenapa? Kan you design shaft, you letak bearing, so you punya lecturer akan complain where is this shaft mount on, you mesti buat ada structure, betul tak? Betul tak kelas your machine component design your project?
Betul.
Mesti ada, every single piece of component must be there, how it mount dalam your structure. The shaft must be spotting dia mount on what? On the frame, on the bracket, so on. Katakan bearing ni ada bracket that hold down the shaft, the bracket. This bracket also mount on the what column? Ada bolt or welder. Semua must be there. Kalau ni ada lah, kalau katakan you have shaft in your component. Must be detail guys. Memang ni memang totally busy, totally detail. This I cakap, I already warn you in the early of this semester kan. Di system design kita don't have test 1, we don't have test 2, we don't have final exam. You are going to be very very busy at this moment. Ni yang you punya penangan. Saya cakap lah, penangan dia kat sini lah. Orang tak ada test, orang tak ada exam. Inilah cerita kau busy sekarang. Pasal ini design work. Detail, kena detail sikit. Faham Distributor kena detail. BOM ada. Boleh tak? BOM ada. Every single component, inverse, shaft, you introduce mechanism, mesti dah. Tak ada yang floating in the air. Semua mesti ada tu. Ini yang korang mesti ada. Ini penting ni guys. Mesti ada BOM. Ikut group. Faham kelas BOM. Overall tadi. BOM. Overall layout. Mula-mula overall tadi. Overall assembly drawing. The whole system dengan case. Itu pun mesti ada juga. Ni. Ini korang dulu ni. Siapa yang champion tu, dia kena buat dulu overall layout. Dia katakan you punya decision from your geometry, the champion, you tak ada buat merging. Okay, so yang the champion tu have to be design layout dulu, and kemudian dia kena the champion tu have to explain to all the team members how we gonna make this thing works. Faham? How we gonna make this thing, your system works. Ni yang kerja dia. So I've been talking about it. Ini peringkat what we call, guys, after conceptual design, you get your final concept, right? This is what we call initial embodiment design. This is the thing. Kita not yet detail design, guys. Detail design tu jangan misunderstood. Detail design tu, nanti detail design is just about engineering analysis and engineering. That is it, and you do fabricating after that. Itu and ergonomic analysis, I explain to you. Itulah during on that stage. Ni initial embodiment design. You kena ada BOM. Okay, mula BOM ni, detail BOM. Nanti, bila you ada list of BOM of all you punya subsystem, then only on the next week, I will explain kita gunakan design tools, kita design for example, design for manufacturing. Syaratnya, to do DFMA, design for manufacturing assembly, you mesti ada list of component involved dalam UP system. Understand me guys? How do you want to know list of component? The one that you're doing right now as you to do. You have to sunan all the list of BOM, every single piece of involved. Nanti kita akan study that BOM of your component that you introduce, then we baru boleh kita gunakan tools DFMA. DFMA mean kita simplify kan. Ni kita reduce a little bit. Easy to assemble, easy to manufacture. Tapi syarat for you to easy to assemble, easy to manufacture, you need complete list of this detail. Every single piece that you introduce, you kena listkan dulu. How do you list? You cannot list by just doing BOM. You kena sketch lah. Kena properly. You have to sketch properly and make a BOM of the one. Identify a component. And also, remember guys, material. Material also. Material ni guys, bukan all material. Okay, certain material you can guess, you can select material based on your knowledge lah, for your information get from standard material that you know. Macam like the beam book structure, kalau I get from the internet or structural beam, okay, that's it still lah. What type of steel they use, you put that material in. Tetapi that material parts that you introduce, certain part like crucial, critical, because involved dengan high loading. Okay, this material you cannot just simply you want to use steel, tak boleh. You have to be careful lah. There is a proper way how to select material. Okay, nanti there will be a talk guys about how we select material, not this week, by lecturer from manufacturing from Fahad. Dr. Nuhayati will give a common lecture. Remember kita ada talk dulu on the project management, right? Ni yang second talk, there will be a second talk of material selection. How you select material on dalam you punya design. How you select material. Not all material you simply select. There's a way, safe way to select material. Okay, dalam BOM tu I mention ada name, you identify material also. Certain yang crucial saja yang you kena tengok lah the top tu. Crucial material tu. Material yang important. Yang material yang standard you can get, tak apa, you can simply select the material. Yang crucial ni yang critical part. Okay, later I also share you ada YouTube video, you can look at that video. So, about material selection. Only on critical part. That material selection only on critical. Critical mean you have to make a big, macam yang you design aircraft lah. You design a bicycle. Ada video tu explain to you about bicycle tu structure. Macam mana dia select material frame bicycle tu yang mana yang really pasal bicycle dia punya frame dia need to be light and strong material. That dia punya frame of that bicycle. Macam the wheel they have a lot of spoke kan. What material of that spokes? Itu crucial pasal the wheel tu supporting the load. The spoke supporting the spoke or a lot of spoke in between the wheel. That is crucial method. Also the frame, the shape, the frame of the bicycle itu crucial pasal dia supporting the load the impact on the wheel and also the weight of the cyclist. Itu crucial material. Macam tu you have to use proper way. I show you a video nanti on the WhatsApp and you can look at that. Tetapi not all material you have to use that proper way. Like simply material you judge based on standard material. Only yang critical. Okay guys, boleh faham apa saya kata? Alright? Ada question? 1 week lah. 1 week you have to do this. Boleh Right. Okay. So I think we don't have class now on that. That's why we need to focus. Tetapi I think guys, nanti next week kena present juga. I tak decide lagi. Tapi it will be next week. Second meeting you kena present to me. Either recorded video in YouTube. You have to make your punya presentation really impressive. Either recorded. During short time saja dalam 20 minutes presentation, everyone must talk. Pasal I will judge nanti presentation on individual. Nanti the format of presentation tu I will inform you. Kan, I think on kita the next class is Thursday kan, no class lah. I want you to focus on this. Ini memang heavy duty punya work lah. Focus on doing this. Boleh Boleh guys?
InsyaAllah boleh doktor.
InsyaAllah.
Okay, macam ni. Pasal ini memang busy moment. Busy moment kita 1 week sekali meeting I give you briefing. I hope you understand apa yang talking about. By next week tu you must be ready lah. Kalau you tak ready, by next week also I want to explain you the FMA. The FMA ni cannot be done kalau you tak ada complete list of BOM. So what BOM you are using right now? All you punya subgroup semua BOM tu misalnya. BOM tu ni, BOM ni kan you learn drawing guys kan. BOM kan bill of material. So you make your sketch ni complete. Every single piece of component must be there. The single screw bolt and nut also must be there. Pasal you kena identify. Bila you ada list of the BOM, baru we can apply the tools of the FMA. Itu will be on the next stage. The FMA kita simplify, kita reduce the component. Dia ada prinsipal-prinsipal kita kena obey lah. Dia ada berapa prinsipal kita kena obey. Kita explain later on next week. Okay kelas. Kalau tak ada question, move attendant. Banyak. Tidak tiap attendant. Lain kali tunjuk muka boleh Boleh kelas. Next class next week apa? Ada sebagian. Alright, good.